Hello friends, welcome to my channel Patra tutorial. In this video I will be discussing about the critical section problem. Okay, so after understanding the basic concept of critical section problem, such as what is rest condition, what is critical section, and what is preemption, what is mutual exclusion, all those things. So let us get into a little depth of critical section problem. Okay, so in this video I will be discussing about what is critical section problem, and secondly I will discuss about what are the different mechanism or different approach to solve critical section problem. Okay, and thirdly I will discuss what are the different requirements that a critical section problem solution must satisfy. Okay, so these are the three agenda of this lecture. Okay, so let me give one example of critical. Suppose there is a program that is, suppose main function is there. Okay, and there are certain lines of codes are there. There are suppose thousands or 2000 lines of codes are there. Okay, and in this program there will be some portion of the program or some lines of the program in which the program will access the public resources or shareable resources. Okay, that means what, in this part of the program, this program is accessing the shareable resources. So this area of the program or this part of the program is called critical section. Okay, so these things we have already discussed. So let me give one scenario. Suppose in a system there are n number of processes are there. Okay, there are n number of processes are there starting from p0 to pn minus 1, and each process has critical section segment of code. Okay, so each process is nothing but what, program only, right? The program under execution is called process. So each process is having a critical section segment of code. Okay, and the process may be changing common variables, and that in that critical section the process may be changing the common variables or updating the tables or writing to the files. Okay, so these are the things the process may be doing, and when one process is critical section, no other may be in the critical section problem. Okay, that is called mutual exclusion. Okay, so in this scenario, see, there are n number of processes are there, and they are trying to update something, some files or some variables. Okay, so in that case we have to synchronize their execution, or we have to execute them in a particular order, so that it will not leads to loss of data or any deadlock situation, right? So this is called a critical section problem. That means what, accessing the critical section at a times only by only one process. Okay, so what is critical section problem? Critical section problem is to design protocol that the processes can use to cooperate. Okay, so we have to design an algorithm or a protocol, and that protocol can be used by the processes to solve or to cooperate among them and access the critical section in such a way that there will not be any data loss or data redundancy or any deadlock scenario. Okay, so that is what the critical section problem is. Okay, so each process must ask permission to enter the critical section in the entry section. Okay, so in every critical section problem there will be one entry section. So let me show you one simple program. Okay, so this is a general structure of the program, a process pi or program. Okay, so this part is called critical section, this part, and before entering into the critical section every process must go through the entry section. Okay, in this section it will check whether there is any other process currently in critical section or not. Okay, if there is any other process running in critical section, then it will not be able to enter into the critical section, and before leaving the critical section it will go through the exit section. Okay, what it will do in this section, it will declare that I am leaving the critical section, and if there is any waiting process to be entered into the critical section, they can enter. Okay, so before entering it will go through the entry section, and whenever it is leaving the critical section it will go through the exit section. Okay, and it will let the other process know the critical that means in critical section no process is running. Okay, so this is the structure of a process with one critical section. Okay, now so we have to what we have to do is we have to synchronize, or we have to provide a order of execution of all the processes, so that the critical section will be accessed by only one process at a time. Okay, and there will not be any redundancy or loss of data or any deadlock scenario. Okay, so now we have to discuss what are the different mechanism to solve this problem, right? Or what are the different approach to process synchronization. Okay, so let me tell about this one. So there are different synchronization mechanisms are there. Okay, so let us see. There are three different approach of or three different solution for synchronization mechanism. Okay, so first one is what? Software approach. Okay, so in this approach we'll be studying three things again. Okay, first one is what? Turn variable, second one is flag variable, and third one is Peterson solution. Okay, so these three things I'll be discussing in software approach. Okay, and in hardware approach we'll be studying again three things. First one is what? Disabling interrupts, second one is test and set instruction, and third one is swap instruction. Okay, so I'll discuss all these things one by one in the subsequent videos. So I'll prepare one video for every approach. Okay, and the OS approach is what? Semaphore. Okay, so these are the different solution or different approach for synchronization mechanism. Okay, so first one is what? Software approach, second one is hardware approach, third one is OS approach. Okay, so in software approach we are studying turn variable, and second one is using flag variable, and third one is what? Peterson solution. Okay, and in hardware approach we'll be studying these three things. Okay, so now let me discuss what are the minimum requirement or means a critical section problem must satisfy to solve the critical section. Okay, so there are some requirements that a critical suppose I am providing one protocol or a solution to critical section problem, so that solution must satisfy three things. Okay, so first one is what? Mutual exclusion. This means what? Only one at a time. Okay, so suppose there are n number of processes or three processes are there. Okay, suppose p1, p2 and p3 are there. Okay, and this is all of them are trying to access the critical section. Okay, so I have to make sure that only one process can access this critical section problem at a time. If p1 is executing in CS, then p2 or p3 cannot be in the critical section. Okay, so this mutual exclusion basically ensure that only one process is executing in the critical section. Okay, so this must satisfy if means every solution must satisfy critical mutual exclusion condition. Okay, and second one is what? Progress. So if no process is executing in its critical section and there exist some processes that wish to enter the critical section, then the selection of the processes that will enter the critical section next cannot be postponed indefinitely. This means what? Suppose let me give one example. Suppose there are three processes are there, p1, p2 and p3. Okay, and first the order of execution is like this: p1, p2, p3, then again it will come back to p1. Okay, now suppose, and the condition is that p1 will execute first, then it will give the chance to p2, then p2 will execute, then it will give the chance to p3, then again p3 will execute, then it will give the chance to p1. Okay, but meanwhile suppose p2 decided not to get into the critical section. Okay, p1 is executing right now and p1 give the chance to p2, but p2 does not want to go to the critical section and p3 is waiting for the critical section. In this scenario, what will happen? Neither p2 is entering into the critical section nor p3 is getting the chance. Okay, that means what? Unnecessarily p2 doesn't want to go to the critical section, but because of p2, p3 is not able to go to the critical section. Okay, so that means what? This is what? Strict alternation. p1 is giving to p2, p2 is giving to p3, again p3 is giving to p1. Okay, that means if p1 is not interested to get into the critical section, then it should not create any problem. Okay, that means progress states that only those processes which are interested to get into the critical section will be competing for the critical section. Okay, and those who are not interested they will not create any problem for the others. Okay, so that is what critical means progress is. Okay, so progress ensure that only the interested process will be competing for the critical section. Okay, and third one is what? Bounded waiting. A bound must exist on the number of times that other processes are allowed to enter their critical section. Okay, after a process has made a request to enter its critical section, and therefore the request is granted. Okay, so what bounded waiting is saying that, suppose there are two processes P1 and P2. Again, P1 and P2, and this is very small process, and this is very large one. Okay, and this P1 is entering into the critical section, coming out, again entering into the critical section and coming out. Okay, and these things is repeating, but P2 is waiting here for critical section. Okay, and P2 is not getting the chance because of repeated execution or repeated entry of P1 into critical section. Okay, so the bounded waiting stating that there must be some a number of times, means there must be some condition that the process can enter into the critical section for a certain number of times repeatedly. Okay, if there is an waiting process, okay, and that is waiting for the critical section. Okay, so that is what bounded waiting is. Okay, so critical section problem, we have to provide some protocol, and that protocol must satisfy these three conditions. Okay, mutual exclusion and progress. Third one is what? Bounded waiting. Okay, but first one is what? Mutual exclusion, right? And second one is what? Progress. Okay, progress. And third one is what? Bounded waiting. Okay, third one is what? Bounded waiting. These two are compulsory or mandatory condition. Okay, these are mandatory condition. Okay, every critical section problem solution must satisfy these two conditions, and this one is optional. Okay, bounded waiting is not compulsory, this is optional one, but every solution must satisfy these two conditions. Okay, so this you have to remember, and in the next video I'll be discussing about turn variable. Okay, how to solve the that is software approach for critical section solution, and how to solve the critical section problem by using turn variable. Okay, so thank you for watching, and if you like my video, please comment, share and subscribe.